here's the problem today. Determine a simplified algebraic expression for the perimeter and area of the rectangle below. So as you can see, we have a rectangle and there are algebraic expressions listed as the dimensions. And so some things to consider here is that we're going to need to use some of our algebra skills to make this question work. So again, we're trying to determine a simplified algebraic expression for the perimeter and the area. So let's begin with the perimeter. We're going to do that work in blue. So if I asked you, so how do you find the perimeter of a rectangle? You may be tempted to try and, quote some fancy formula. Well, perimeter, forget the fancy formulas. If I asked you, what is perimeter of a shape? Hopefully you'd say, oh, it's just the distance around the shape. So it'd just be like how long it is from here to here to here to here. Well, hopefully, if you think about it for a little bit, you realize you just have to add up those dimensions. And so to make an expression for the perimeter, P equals, well, I'm just going to take these dimensions and add them up. So 3x plus 2 plus 2x, and that's it, right? No, because that's just two sides of the rectangle. So we have to add another 3x plus 2 and another 2x. There's all four sides to our rectangle. Now, we have to determine a simplified algebraic expression. Look at this. We're just adding a bunch of monomials together. And so when you do that, it's the same as just adding monomials. We look for like terms. So if we just reorganize the question, we end up with 3x plus 2x plus 3x plus 2x, and then what? Plus 2 plus 2. Simplifying now, well, 3x plus 2x plus 3x plus 2x, that's 10x. 2 plus 2 is 4. There's the simplified algebraic expression to represent the perimeter of this rectangle. Let's move on to the area now, and we're going to do that in green. So now, if you ask yourself, so how do you find the area of a rectangle? Hey, there is a formula that we have to use for that. It's length times width. So I'm just going to write that down. I'm going to put it in a little, fluffy cloud, but then I'm going to move it out of the way here. Just, it gives us something to think about. All right. So now if I asked you, well, what is the length and what is the width of this rectangle? Well, you could say that the length is 3x plus 2. And you could say that the width is 2x. And you're fine to write it in that order, but when it comes to other expressions we've simplified in the past, it would look much better if we just reordered what we had. And since it's multiplying, we can do that. So 2x times 3x plus 2. Hopefully you're looking at that going, hey, that looks a lot like distributive property. I have a monomial in front of the brackets, right? There it is. There's the monomial. And I'm multiplying it by a binomial that's in the brackets that immediately follows. So how do we do that? Well, it's just 2x. 2x times 3x. And then 2x times 2. Well, what's 2x times 3x? 6x squared plus 4x. And there, we have a simplified expression now for the area of that rectangle. Now very quickly, if you're like, so why do we even do this? Well, if now you were told, x is equal to 2, it would be much easier at this point with these simplified expressions here and here to plug in your value for x and evaluate. It would be much harder to plug it in the unsimplified expressions. Okay? So that's why we simplify expressions, so that when we are then finally given the value for the variable, we can plug it in and evaluate much easier.